Okay, this is the last section of problem 7.3.7. Ask find the covariance of B and T, and are B and T independent or not. We just know that B and T are conditional independence, but we don't know anything about that these two random variables are independent or not. At first, we have these tables in previous section in part C, and when we want to check that they are independent or not, we need to calculate the probability of B, and we need to calculate the probability of T, and then check that they follow these formula or not. For calculating we have these variable in these tables, but for calculating the marginal probability of B and marginal probability of T, we know that this is the marginal, the summation of the rows. Each row say to us the marginal probability of a special value of the B. For example, this is the summation is 0.4, the summation of the first row, and this is for the probability of B when B is equal 1, it's equal 0.3, and this is 0.3. And so we sum together. For calculating marginal probability of the T, we should add the columns, each columns with together. So this is equal 0.4, this is 0.2, and this is 0.4. Okay, and if we want to calculate, if we can find just one value, one of the value that doesn't follow this formula, so we can then make a conclusion that they are not independent. At first, we started with the first value, that the probability of B and T at 0 and 0, that from the table it's equal 0.2. Is it equal with the probability of B at 0 and the probability of T at 0? The probability of B at 0 from here, we know that is 0.4, and probability of T at 0 is 0.4. The we multiply it together, it's equal 0.16. That is not equal with 0.2. So B and T are not independent. But what is the covariance of them? In order to calculate the covariance, we need the covariance of B and T, it's equal to the expectation value of the BT minus the expectation value of the B times the expected value of the T. So we need to calculate each of them separately. The expected value of the B, it's equal to the summation B times the probability of B for all possible value of the B, that is equal from 0 to 2. So this is equal, for the 0, because 0 point times with each probability is equal 0, so we start from 1. 1 times the probability of B at 1 from here is 0.3 from the table, and the 2, the last possible value of the B times to its probability, that from here is 0.3. So this is equal 0.9. We calculate the expected value of the B. For T, we do the same for all possible value of the T until 2 times T times the probability of T. So at 1 times it's equal 0.2 plus 2 times that this probability is 0.4, and it's equal with 1. Okay, so the expected value of the T is 1. In order to calculate the expected value of BT, we can rewrite that it's equal to summation of B BT times the joint probability of PT. That again we have from the above table. For all possible T start from 0 to 2 and B start from 0 to 2. So we have these pairs value when T and B are equal 1. Their joint probability is 0.06 from here. When B and T is equal 1, yes, the joint 1 times the probability of 0.6 and plus and when B is equal 2 and T is equal 1 times to the probability of 2 and 1 that it's equal 0.12 plus when 1 is, this is the multiplication, so I mean that this is times, and this is when B is equal 1 and T is equal 2 times to joint probability between them, and when both of them are 2 to probability of 2. So this is equal with 1 times 0.06 plus 2 times 0.12 plus 2 times 0.06 plus 4 times 0.16. That the total value is equal 0.6. So the covariance of B and T, it's equal to the expected value of BT minus the expected value of B times the expected value of the T, and it's equal 1.06 minus this one and this one, so it's equal 0.16. Thus, badness B and time watching football T are positively correlated. This should seem odd since B and T are uncorrelated for men and also uncorrelated for women. However, men tend to be bolder and watch more football, while women tend to be not bold and watch less football. Average over men and women, the result is that boldness and football watching are positively correlated, because given that a person watches more football, the person is more likely to be a man and thus is more likely to be a bowler than average. So this is this problem set. The next video we're going to go to problem 7.42.